Good morning, everyone. This is Dr. Mamaguzan. Today, I'm going to discuss about thermodynamics. Thermodynamics basically the study of flow of heat or any form of energy into or out of the system as it undergoes a physical or chemical transformation. That is basically the study of thermodynamics is a part of physical chemistry where you are finding out by this word also the term thermo means temperature or heat, dynamics means the flow of heat or that whole process through that. So that's why it is said to be thermodynamics. In studying the thermodynamics and evaluating the flow of energy into or out of the system, and it will be very much useful to consider changes in certain properties of the system. These properties include temperature, pressure, volume, and concentration of the system. The study of thermodynamics is based on three broad generalizations derived from well established experiment results. The generalizations are known as first, second, and third law of thermodynamics. These laws have stood the test of time and are independent of any theory or the atomic or molecular structure. What is the scope of thermodynamics actually? Most of the important laws of physical chemistry, which includes Van 't law of lowering of vapor pressure, distribution law, phase rule, are derived from the laws of thermodynamics only. And thermodynamics also tells you whether a particular physical or chemical change can occur under a given set of conditions of pressure, temperature, and concentration also. Thermodynamics also helps in predicting how far a physical or chemical change can proceed under the equilibrium conditions which are established. But thermodynamics are also having some limitations, like thermodynamics is only applicable to macroscopic systems, not microscopic systems, because thermodynamics is applicable to macroscopic systems consisting of a matter of bulk and no to microscopic systems of individual atoms or molecules. It also ignores the internal structure of atoms and molecules. Thermodynamics does not bother about time factor just like chemical kinetics, because there we are talking about the change in the concentration with respect of time, the change in the concentration of a product or a reactant with respect of time. But when we are talking specifically about thermodynamics, so here what happened, like we are talking about a system, that system which is executing, but we are not bothered and we are not panicked about the time factor. So that's why it does not tell anything regarding the rate of physical change or chemical reaction. It is concerned only with the initial and the final state of the system. Thermodynamics are having different systems also. Like when we are talking about a system, so that system means like we are having a part of the universe which is under thermodynamic studies, and the rest of the universe is surroundings only. You can see from this picture also that this is a system, these are boundaries, and this is surrounding. If you are considering your one use one beaker in which you are having some solution, so we are talking about this particular solution as and considering as your system, and the outer layer of this beaker is said to be your boundary. And when you are placing your beaker in some environment like in laboratory, that is said to be your surroundings. So in this way, we are talking about system. System plays a very important role in thermodynamics because we are observing here whatever the changes will physical or chemical transformation forms in that system, and then we are analyzing other properties of that particular system. The real or imaginary surface separating the system from the surroundings is called boundary actually. When we are talking about boundary, so this is about the real or imaginary surface which separates the surroundings, then it is said to be your boundary. Now we are going to talk about types of systems. Here you can see that we are having three different types of system. One is open system, closed system, isolated system. Open system means like where we are having systems in which the boundary is open and uninsulated. You can see from this figure also that this is a kind of a boundary. This is kind of an open system where you are having a boundary which is open and uninsulated. Therefore, an open system is that kind of a system which can able to transfer both energy and matter to and from its surroundings. Like here, you can pour this solution which is inside this particular cup, and after that, this is an open system. We can say in that way because energy can also be transferred, and the matter which is inside this system can also be transferred. Now we are moving to closed system. This is one example of closed system, which is a thermoflask, which is totally closed. So in that, what happened? Like a closed system is said to be a that kind of a system where the transfer of matter cannot take place, but transfer of energy in the form of heat, work, and radiation to and from its surroundings. So this is one kind of a closed system. When we are talking about isolated systems, so isolated systems are those systems which can neither transfer heat nor energy and from its surroundings. So this is an closed system, this is an isolated system, this is an open system. These are some examples of that. Here also it is written like systems may also be defined as a specified part of a universe in which energy changes are taking place. Now we are going to talk about different properties of a system. We are having, but before that, we will talk this also about the part of systems. System has been classified into two parts. One is homogeneous system, another is heterogeneous system. What is the difference between homogeneous and heterogeneous systems? First, when we are talking about homogeneous systems, so homogeneous systems are basically the uniform systems throughout, and that's why it is said to be homogeneous system. For example, a pure single solid, liquid or gas or mixture of gases and a true solution of solid in a liquid is said to be a homogeneous system. Or we can take one example that when we are pouring sugar plus water, we are making a homogeneous solution. That homogeneous solution is said to be a homogeneous system, and that homogeneous system is comprising of only one phase, that is a single phase. That's why a phase is also defined as a homogeneous, physically distinct and mechanically separable portion of a system. On the other hand, if we are talking about heterogeneous systems, these systems contains two or more phases and the composition is uniform throughout. Or we can say that a heterogeneous system is a kind of a system in which it consists of two or more phases. It is not uniform throughout. Example of heterogeneous systems are ice in contact with water, ice in contact with vapor, ice in contact with means vapor constitute separate phases like that. So when we are talking about heterogeneous system is not uniform throughout, and it is having two or more phases. Here you can see by this picture also there are some examples like when we are talking in general open system. In open system, both mass and energy cross the boundary. That's why these are examples of open system: pump, compressor, turbine, heat, and exchanger. When we are talking about closed systems, so those closed systems are those systems in which only energy can cross the boundary. Refrigerator and AC are the perfect examples of closed system because when we are using AC and refrigerator, if AC is running in a room, then what happens? The ejection of heat takes place outside that particular room. So this is a kind of a closed system. Refrigeration also inside it is cooled and outside it is ejecting heat. So this is a kind of a closed system where mass cannot be transferred but energy can easily transfer. If we are talking about isolated systems, so those are those systems where no transfer of heat and energy can across the boundary takes place, thermoflask and universe. In this, by this picture, you can see that no mass and energy can transfer from this system, so that's why it is said to be isolated systems. Now we are going to talk about thermodynamic properties. See, thermodynamic properties are also very important properties. Why? Because it defines the characteristic of a system. Like when we are talking about pressure, temperature, volume, mass, it defines the characteristics of the system. And on that, why? Because of that reason, thermodynamic properties are usually divided into two parts. We can say like the macroscopic or bulk properties of a system can be divided into two parts. One is said to be your intensive properties, another is said to be your extensive properties. Intensive properties are those properties which does not depend on the quantity of matter present in it, or it does not depend on the size of the system. It mainly depends on the nature of the substance present in it. So this is very much important to understand the difference between those properties, extensive and intensive properties. Some examples of intensive properties are pressure, temperature, density, concentration, refractive index, viscosity, freezing point, boiling point. These are some of the examples of your intensive properties. On the other hand, when we are talking about extensive properties, then what happened in that? Extensive properties are those properties which does not depend on the quantity of matter, which depends on the quantity of matter present in it and which depends on the quantity of matter present in the system. For example, we are taking in consideration like number of moles, enthalpy, entropy, Gibbs free energy, volume. These are said to be the extensive properties of a system. By definition, the extensive properties are the additive while intensive properties are not additive one. So, if we are considering a glass of water, if we double the mass of water, the volume is doubled. And so, the number of moles and the internal energy of the system will also be doubled. So, in that way, we are having common properties of a system like extensive properties can be considered like mass, volume, internal energy, enthalpy, entropy. These are the perfect examples of extensive properties. So for today, I'm concluding my lecture here, and in our next class, we will talk about processes and different thermodynamic processes and how the processes are very much important for a thermodynamic system.